Number 15, be able to apply both the combined gas law and ideal gas law to determine an unknown quantity. I think given the numbers, you can plug and chug into P1 times V1 over T1 equals P2 times V2 over T2, or if you're given the ideal gas law. You guys seem pretty solid on that. I put 3 examples up here of the type of questions that historically IB likes to give you, and they tend to trip people up. So let me show you how you solve these, and we'll look through all 3 of these. So it says, if the pressure is halved and the temperature tripled, what happens to volume? So we're looking at P1 times V1 over T1. And in my second situation, P1 has become 1/2. T1 has become 3 times. And I want to know what happens to V2. So if I rearrange this equation, what I'm really looking at is V2 is equal to P1 times V1 times 3T1. I get that when I cross multiply. And then I divide by T1 and 1/2 P1. So when I look at this, what I'm ending up with is I'm going to have P1s cancel out, T1s cancel out, and I'm left with 6 times V1 as being my new value for V2. So my volume increases by a factor of 6. On my second one, if the pressure is tripled, so again, I'm starting with P1 times V1 over T1 equals P2 times, oops, I'm not going to fill that in yet. So my new conditions are the pressure is tripled, so it's 3P1. The temperature is half this time, half of T1. And again, I've got V2 here. So if I arrange for V2, V2 is equal to the P1 V1 and the 1/2 T1 divided by T1 and 3 P1. So T1 and P1 go away. And my 1/3 and my 1/2 get together, and V2 is now equal to 1/6 of what V1 was. So it decreases by a factor of 6 in this case. And then the last one, V1 times P1 over T1. The pressure is cut by 1/4, so 1/4 P1. Well, the volume is cut by 1/3 volume. What will happen to T1? So again, when I cross multiply and take a look at this, I've got, or T2, I'm sorry, this one needs to be T2 here so I can solve for something. So T2 is going to be equal to T1 times 1/4 P1 times 1/3 V1 over V1. Oh, I just screwed that up. Let me try that again. T2 is going to be equal to, oh, I did have that right. I'm losing it here. It's getting late. T1 times 1/4 P1 times 1/3 V1 over V1 times P1. So these two variables both go away, and I am left with T2 being equal to 1/12 of what T1 was. So it decreases by a factor of 12.